Yeah, welcome back, guys. Today my topic is constraints relation in NLM topic. From last I will come. So next contact bodies, then after momentum, some forces I'll explain. So maximum constraint relations, there are many problems are there, and this is a major topic related to friction, work power energy, rotatory motion. So in all those chapters, these basics are important. That's why constraint equations we'll study. So constraints equations are four types: general constraints, pulley constraints, wedge constraints, and a combination of wedge and pulleys. So first, the easy topic, general constraints I'll explain. So in general constraints, only two methods will follow. Only two methods. So that is, so here I have taken examples. So first method is method one. That is length is constant. Length of the string is constant. Length of string is constant. The second method, the relative velocity is zero along the string. Along the string, relative velocity of the particles is zero. That means the component of velocities are equal. Velocities along the string are equal. Along the string are equal. So these two methods will follow, and all the constraints equations are become easy. So now you can see first constraint here. So see here. So A is dragging like this with velocity u. Then B will move up, right? The B will move up. So the velocity of B is upwards, where A is moving in this direction. So you observe clearly, this velocity is not along the string, right? So here theta is given. So therefore I will take here, that is along the string, the velocity of this one, and here velocity of the B is along the string, right? Velocity of the B is along the string, but velocity of A point is not along the string. Therefore I can change into u cos theta along the string. So this u along the string I can change into u cos theta. Therefore VB is equal to u cos theta. This is by method of relative velocity. So the same thing we will get by using length of the string is constant method also sequence. So your length of the string is equal to this is, right? This is the length of the string. So now consider this is y length. Y is the length changing, and here the gap between pulley to this length is not changing. So your length is changing. The change in length is called u, velocity of point A, and this y is velocity represents the change in displacement of B dy by dt will be Vb. So now if we see now, this length will become here from O to A. So now this length is y, this is x. Therefore from the diagram, so this is so like this. So y x, this root over y square plus x square. So now total length will become here, length of the string is equal to y plus root over y square plus x square is equal to length of the string. Now that implies, now derivate it with respect to time dy by dt with the velocity of black B, and here root x. We are derivating means 1 by 2 root x. that equal root over y square plus x square, and here I'm doing with x with respect to x, then y is equal to constant here, so that will be 2x is equal to dl by dt 0. So these two get cancelled. So this is vb. So vb, velocity of the black, plus if you see here into dx by dt, this is into dx by dt has to come. I'm derivating the x with respect to time. So now dx by dt I said u. If you see from the diagram here, x by root over means x is, for here theta we have taken in the diagram, if you see adjacent side and hypotenuse. Therefore adjacent by hypotenuse means cos theta is equal to 0. That implies the vb is equal to minus u cos theta. So this is, your minus indicates direction of vb and u directions. So this is from displacement method. So this is a solution for 1. So second example we'll see. If you see second example, so in the second example here similar. So v1 of this block is left side and v2 is upward direction. So clearly this length is called length of the string. It will not change, right? It will be constant according to general constraints concept. And this is x1. X1 is changing. The x1 change. The x1 represents what here? X1 represents the velocity of v1. The change in x1 represents velocity of, with respect to time, represents v1 velocity of this block. And x2, the change in x2, that means dx by dt, dx2 by dt is equal to the velocity of this block b, consider. So b, v2, and dx1 by dt is equal to v1. So now the velocity, this velocity v1. So now consider here diagram. To consider here second diagram. Solution for second one. So diagram is like this. So here is the pulley. So this is velocity v1, and here velocity this is v2. Now, so if we consider here angle theta, so wherever I can give, but here I am taking angle theta. So the velocity is resolving into this direction. So that equal to v1 cos theta. So v2 is already along. V2 is along string. Therefore, v2 is equal to v1 cos theta. These are magnitudes. Direction means it is my j cap. This is along xy, v1 cos theta. Therefore, v1 I cap and v1 sin theta j cap we can take. So magnitude is v2 is equal to v1 cos theta. So if we coming into length concept, the length is constant here. So this is x1, x2. With respect to time, this height will be constant. With respect to time, this height h is constant. Therefore, so the length L is equal to root over h square plus x1 square plus x2. So now derivation with respect to time, dl by dt is equal to, root x is equal to 1 by 2 root x, h square plus x1 square into, again x1 I am doing 2x x square, I am doing x1 square, that equal to 2x1 into dx1 by dt. This is in and out rule, plus dx2 by dt. So now dl by dt, L is constant. So we know derivation of a constant is 0. That is equal to, here 2 get cancelled. From the diagram if you see, so this is theta here. Then this is 90 minus theta. And again here theta will come because these two lines are here, theta will come. These two lines are parallel, and this length here, what is given, that is transverse line. Therefore, x1 by root over h1 h square plus x1 square will become as cos theta, and dx1 by d2 is equal to v1. Therefore, v1 cos theta plus v2 is equal to 0. Therefore, v2 is equal to minus v1 cos theta. So that is along the string, v2 and v1 are in opposite direction. I hope these two methods understand. So how to take the length and the length and component of velocity along vectors. Now, similarly, other examples here. So there I have given 6 examples minimum. So in example 3, here there is a gap. I will explain here itself. So V. So this is not in the direction of string. It is horizontal. So here theta is given. So this is 90, then 90 minus theta. So I can change the V into direction along the string. So actually this is the velocity of block VB. It is theta means 90 minus theta. So V2 along this direction. Therefore, here V2 into cos 90 minus theta. Sin theta, all are positive in 90 first coordinate. V2 sin theta along the string is equal to V. So this is we are going to prove now. So by length method, h square plus x square. Here h is vertical height and x is the variable that is represents the dx by dt represent velocity of 2 means body, this mass, velocity of mass. And here this is x1. Here to here this is the x1. So x1 is the variation of length by pulling v velocity. So now h is constant. So I am derivating with respect to x with respect to t, 2x into 2x by dt into 1 by root x, you know answer. So this is common everywhere. So dx1 by dt equals 0. Therefore, you will get here x dx by dt represents v2. Dx by dt, here x is variable representing the motion of m. Therefore, dx by dt is v2. X by, here see theta is here I have taken. Therefore, x by root over x square plus x square is equal to sin theta or equal to minus v. So minus v and v2 sin theta are indicates directions. That's enough. So here if you see clearly, so here theta, then it will be v2 cos theta, v2 sin theta, so cos 90 minus sin theta. If sometimes they will give here theta, so then this is here theta means here theta will come v2 cos theta is equal to v. So like that. So here v I can't resolve. So this v2 only I can resolve, but v not, because this v already along the tension. So that is. So now coming into example 4. So in example 4 already I have given concept related to length method and all. So if you see here, this is some mass and here another mass supported by the pulley. Now this mass, stone or some weight is going down, that is represents y1 distance. Then m2 will come out. So where you are lifting the gates, so this method, railway gates, this method will follow. So now if you see here, the x between pulley and this length, this stand is constant. Y2 is variable that represents the velocity of m2, and y1 is variable that represents the velocity of v1. So now root over, from this diagram, root over x square plus y1 square plus y2 is equal to constant. That is the length of the string. This length of the string. So now from that again, if we solve means, here you will get, I am derivating here y1. I am derivating here y1. So therefore, 2y1 into dy1 by dt into 1 by 2 root y1 square plus x square is constant, plus dy2 by dt is equal to 0. That means it is clear. So dy1 by dt is velocity of v1. So that means y1 by, here y1. So here consider theta now. So that is y1 by hypotenuse means sin theta. That means v1 sin theta is equal to v2 minus v2. v1 sin theta is equal to v2. So is it correct or not? We will check now. So see, this is the v1 direction. So it is not along the string. So we have to resolve this along the string now. So here this is theta. Here now perpendicular in this way. So this is 90 minus theta. Here also 90 minus theta. So in this direction. So in this direction we will get the v1 cos of 90 minus theta, that equal to sin theta will come. So therefore v1 sin theta is equal to v2. So this is writing constant equation. So similarly all constants equation. See now here also. So this v1 and v2 both are not along the string. Therefore here we will get finally v1 cos theta 1 is equal to, so v1 cos theta 1 is equal to v2 cos theta 2. So theta 1 equal to theta 2, then v1 equal to v2. v1 equal to v2, then theta 1 equal to theta 2. So v1 by v2 is equal to become cos theta 2 by cos theta 1. If theta 1 equal to theta 2, that equal to v1 equal to v2. Right. Now displacement method, this vertical displacement is constant here. So only this x1 and x2 are variable. So x1 represents the v1 and x2 represents the v2 velocity. The rate of displacement in x2 is v2. The rate of displacement in x1 is v1. And this vertical displacement y is constant. Therefore, so this will become dx1 by dt into x1 by, so x1 here theta 1 means this is 90 minus theta 1 here. So this is 90 minus theta 1. Sin of 90 minus theta 1 is equal to cos theta 1 is equal to x by root over this one. Therefore, cos theta 1 I can write. Sin of 90 minus theta 1 equal to cos theta 1. So this is also x2 means dx2 by dt into, you will get x2 by root over this hypotenuse. Here also here theta 2 is given. This is 90 minus theta 2 from the diagram, 90 minus theta 2. Sin of 90 minus theta 2 is equal to, for 90 minus theta 2 opposite is x2. Therefore, sin 90 minus theta 2 is, you can write as cos theta 2. The cos theta is equal to opposite side here, because sin 90 minus theta 2 is equal to cos theta 2, that equal to opposite by hypotenuse square. Therefore, cos theta 2 will come. So that equal to 0. So you receive the answer. Means you got it here v1. So dx1 by dt represents x1. dx by dt represents cos theta 2. So v1 cos theta 1 equal to v2 cos theta. In the general equation, maximum velocity, and derivating this one will get aberrations. So with respect to time, not theta, with respect to time, dv1 by dt is equal to a1. Theta we are not respecting, derivating. So now, so these are like that. You can go with a number of examples here also. Finally, example 5 C1s. So you'll get clarity. So this mass is moving down with velocity v1. That means the length of y1 is changing. That represents dy1 by dt represents v1. dy1 by dt represents v1. Similarly, here x is, I have considered here x. dx by dt represents v2. So now this length from here to this support to this pulley is not changes whatever the time. So therefore, the length of this string is equal to x square plus y square plus y1 equal to constant. So we are derivating this with respect to time x. dx by dt into x by root over x square plus y square will come. From many of the problems we are solving like this only. So directly I am writing dy1 by dt is equal to 0. Means derivating this root x and 2x, you will get answer like this. 2 to get cancelled. So here x, theta I have taken here, x means cos will come. X is adjacent side for theta, therefore cos theta. Therefore dx by dt is v2. v2 cos theta is equal to, so v1. So similarly v2 along the cos theta, this direction, v2 cos theta will come along the v1 is direction. So v2 cos theta is equal to v1. So velocity along this string